Hi there, so today's lesson is topic 2.5, powers, exponents, and square roots. And we've got three objectives today. We're going to use exponents to write repeated factors. We're going to simplify expressions containing exponents, and we'll also find the square root of numbers. So our key words for this lesson are the words exponent and square root, and they are inverse or opposite of one another. So the exponents, where we have that little guy up high, so like 3 squared. And 3 squared means 3 times 3, not 3 times 2, which sometimes when we're tired or we're just in a habit, we actually do that 3 times 2, which we should not do. Square root is the opposite, so this is shown by the square root symbol. And so this is where we are going from a number like 9 down to what was squared to make that number. So the square root of 9 is 3 because 3 times 3 equals 9. So when we have something like that 3 squared, where we have that repeated multiplication, repeated multiplying of a number by itself, it's easier to write it in this exponent or power form. So where we have 2 times 2 times 2 times 2, we see that the 2 is our base. So this is our base here. And then the exponent is how many times it is multiplying by itself. So 2 to the power of 4 means 2 times 2 times 2 times 2. This is especially good to show brackets when we have an integer. So -3 times -3 times -3 times -3 times -3. That gets tiring to say. So it's a lot easier to say -3 to the power of 5. Where -3 is the base and 5 is the exponent. We can also show exponents to fractions. 3/4 times 3/4 times 3/4 is the same as 3/4 cubed, or 3/4 to the power of 3, where 3/4, the entire thing, is the base, and 3 is the exponent. So using brackets here is really handy because it doesn't just mean 3 to the power of 3, it means 3/4 to the power of 3. So let's evaluate the following. We have number 1, -1 to the power of 5. This means -1 times -1 times -1 times -1 times -1. This can get tiring to write, so we're going to look at a little bit of a shortcut. But if we do this step by step, -1 times -1 is +1. +1 times -1 is -1. -1 times -1 is +1. And +1 times -1 is -1. So we see that if we have an exponent of 5, our answer is going to result in a negative number. Let's check out what happens with a positive number. -1, and this is a positive exponent, sorry, an even positive exponent. -1 times -1 times -1 times -1 times -1, that's 5 of them, 6, 7, 8. Okay, we go through. +1 times -1 equals -1 times -1 equals +1 times -1 equals -1 times -1 equals +1 times -1 equals -1 times -1 equals +1. Phew! That takes a long time. So we have a rule that can help us, and this rule is called EPON for short. If the base is negative and the exponent is even, so even, then the answer is going to be positive. If the negative base has an odd value, then we're going to see a negative answer. So let's look again at number 1. We have -1 to the power of 5. So this is an odd number. Because the base is negative and we have an odd exponent, we're going to have a negative answer. This is the ON of the epon. Compared to number 2, where we have a negative base and we have an even exponent. This means that our answer is going to be positive. So when we see negative 1 to the 5th power, we can be assured that the answer will be negative 1 because the exponent is odd. And if we see negative 1 to the 8th power, we can be assured that the answer will be positive 1 because the exponent is even. So when we square a number, like 5, and we square it, we are multiplying that number by itself. And the result is called a perfect square. In this case, the perfect square is 25. When we want to find the square root of a number, we are looking for the number that multiplies by itself to form that given number. If the number is not a decimal, then it's called a perfect square, and we can easily square root it. So when we take the square root of 25 and we write our answer as 5, what we are acknowledging is that it's 5 times 5. That makes the 25. Another perfect square is 81. When we look at the square root of 81, we're asking ourselves what times itself makes 81? And the answer is 9, because we know that 9 times 9 equals 81. So some perfect squares that are very common for us are 4 and 16, 25, 36, 49, 81, and there are many, many more. So when we take the square root of these numbers, we see 2 times 2 makes 4. 4 times 4 makes 16. 5 times 5 makes 25. 6 times 6 makes 36. 7 times 7 makes 49. 9 times 9 makes 81. And we have other perfect squares, like 9, 64, 100, 121. There are many, many perfect squares. So for the do together, number 1, it's asking us to find the square root of 100. So we're asking ourselves, what times itself equals 100? And we know that 10 times 10 equals 100. So the square root of 100 is 10. For number 2, we're going to evaluate negative 3 to the 3rd power. Remember, we can use epon for the sign because the base is negative. So we have an odd exponent, and if we have an odd exponent, the answer is going to be negative. So we can put the negative sign, and then we can multiply 3 times 3 times 3, knowing with confidence that the answer is going to be negative. So 3 times 3 is 9, and 9 times 3 is 27. So negative 3 cubed, or to the 3rd power, is negative 27. So epon can help us a lot. If you'd like to go ahead with me to the exercise, I'm going to do these 8 questions, or you can work on your own on exercise 2.5. But let's start with number 1 for those of you that want to continue the video. So number 1 is 8 squared. We know squared means multiplied by itself. And 8 times 8 is 64. Number 2 is 4 squared. 4 squared means 4 times 4, which is 16. For number 3, we have a negative 5 base with an odd exponent. So if we write epon above, it can help us remember. So 3 is an odd number, so the answer will be negative. And then I can do the work below, 5 times 5 times 5. 5 times 5 is 25, and 25 times 5 I'm going to figure out 5 times 5 is 25, and 5 times 2 is 10, plus 2 is 12. So 5 times 5 times 5 is 125, and it's going to be a negative 125 because the exponent is odd. For number 4, we have 7 squared. The brackets might look funny there, but the brackets are to show you the sign, and in this case it's a positive number. So 7 times 7 is 49. For number 5, we have negative 2 to the 5th power. Again, our exponent is odd, so that means that our answer is going to be negative. And we can go ahead and figure out 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And this is going to be a negative 32. Now you can go number by number with the sign, negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And you can switch the sign every time, as I showed in that first example. That's okay, but it can get confusing. So EPON can help you a lot. Number 6, we have a negative 3 to the 4th power. 4 is an even number, so the answer is going to be positive. So I'm going to take 3 times 3 times 3 times 3, and I'll determine that step by step. 3 times 3 is 9, times 3 is 27, times 3. So we're going to have to take that maybe and do that on the side. So 21 and 6 and 8, that's going to be 81. And the answer will be a positive 81. Number 7, we have 9 squared. That's a positive 9, so it's just 9 times 9, which is 81. And number 8, we have the square root of 36. What times itself makes 36? 6 times 6 equals 36. So the answer there is 6. So you can go ahead and finish up the next page of exercise 2.5 on exponents and square roots.